the battery that outperforms Tesla's 4680 battery system. Today we are talking about the radioactive diamond battery that will run for 28,000 years. It's powered by nuclear waste, but still safe for humans. But what is NDB? NDB, or Nano Diamond Battery, is an innovative energy generator and storage that redefines and revolutionizes the battery as we know it. Its long-lasting properties and longevity are ensured by converting the radioactive decay energy from nuclear waste into energy. In less than 2 years, you might be able to buy a smartwatch powered with a radioactive diamond battery that will outlive you and your progeny for generations. The potentially game-changing battery comes from the San Francisco-based startup Nano Diamond Battery, which lauds its namesake high-powered diamond-based alpha, beta, and neutron voltaic battery for its ability to give devices lifelong and green energy. Imagine, just one battery could power your insulin pump or pacemaker for your entire life. Or it could provide the juice for a space rover, collecting Mars regolith samples for decades without any human assistance. Those are ambitious goals. So, could NDB's bold claims actually become reality? First, let's dissect the specs. To build its Nano Diamond Battery, NDB uses layers of impossibly tiny, paneled nanodiamonds. Diamonds have exceptional heat conductance, which makes them ideal for electronic devices. In fact, they are the best-known natural conductor of heat, according to a publication by the University of Houston's College of Engineering, and are 3 to 4 times more effective than copper or silver. Scientists cultivate these miniature diamonds using chemical vapor deposition, a process in which gases at extremely high temperatures force carbon to crystallize on a substrate material. That process, NDB admits, creates a cost bottleneck, making the special diamonds as energy-intensive and expensive. After all, they're artificially boron-doped diamonds, explains Yuri Gagauzzi, director of the A.J. Drexel Nanomaterials Institute at Drexel University in Philadelphia. That process produces diamonds with blue color and higher conductivity than the average diamond. True blue diamonds are naturally occurring on Earth, but they're rarer and even more expensive than artificial blue diamonds. Why blue diamonds? The diamonds in NDB's battery have a beautiful blue hue, thanks to the trace amounts of boron contained in their carbon structure. These blue diamonds are artificial, but are reminiscent of true blue diamonds, which are some of the rarest gemstones on Earth. According to findings from an August 2018 study in Nature, they're formed in Earth's lower mantle, which is about 410 to 1,680 miles below the surface. As such, you can only find blue diamonds in 3 mines in the entire world, which helps explain their hefty price tag, roughly $15,700 for a 0.3 carat light blue diamond, and $75,000 for a 0.25 carat dark blue diamond. Once NDB has sourced the nano diamonds, the company combines them with radioactive isotopes from nuclear waste. Specifically, they use radioactive isotopes of uranium and plutonium, which probably come from radioactive power plants' waste. Gagauzzi says, from there, single crystal diamonds, just a few square millimeters in size, move heat away from the radioactively decaying isotopes so quickly that the transaction actually generates electricity. The decay sources deposit their energy onto the NDB transducer, which converts the kinetic energy of the incident radiation to electrical energy, says Nima Galsharifi, CEO of NDB. You're probably wondering what the catch is. There's a diamond battery out there that really uses nuclear waste, lasts thousands of years, and involves layers of only the most minuscule diamonds. It's slightly more complicated than that. Each battery cell will produce only a small amount of energy, for one thing, so scientists must combine the cells in huge numbers in order to regularly power large devices, raising the cost a great deal, along with increasing the complexity. Galsharifi touts the tiny size of the Nano Diamond Battery cells as an advantage for scalability. Though, take the battery for a wristwatch, for instance, it consumes around 2 microwatts. A much smaller NDB cell would be sufficient, he explains. So if we need to power a different application, the number of stacked cells can be increased to meet the demand. Still, there's the issue of wear and tear. Researchers implant the nuclear waste inside the diamond cells, which creates a natural structural weakness that, statistically speaking, will eventually fail in some of the cells over time. Gagauzzi explains, when the Nano Diamond Battery becomes widely available in the future, there's a chance that some of the cells will break or simply go to waste with the devices that they power. This creates an issue of nuclear waste, which is inevitable if large numbers of batteries are used. Gogotsi says. Some of them will eventually break apart. This may not be an issue in space, but will certainly be a concern on the surface of Earth. That doesn't mean the diamond battery isn't a worthwhile pursuit. If those issues are addressed, some possible applications for it include long-term use devices like hearing aids or pacemakers. Take a child that gets a hearing aid implanted or an elderly person with a pacemaker. People shouldn't have to go through the possibly traumatizing surgery more than once. Gal Sharifi explains. The batteries could even prove useful in space vehicles that need to run for years without help. NDB says. Cake satellites, for instance. NDB's claim that the battery lasts 28,000 years is based, in part, on these low-power space applications. Voyager, NASA's iconic space probe, meant to study the outer solar system when it launched back in September 1977. Used 3 multi-100-watt radioisotope thermoelectric generators for power. Each generator's power output began at just 158 watts, which is less energy than you'd need to power a household light fixture for a year. And if enough of these diamond battery cells are combined, they could still power electronics here on Earth with higher energy demands, from LED displays on tablets to mobile phones. But for its first commercial product, NDB plans to introduce a smartwatch, with an expected launch date sometime in 2022. If that really happens, you could own one watch with a single battery and pass it down for generations without ever needing a replacement. Talk about an heirloom. Still, NDB plays its cards very close to the vest, divulging few of the nitty-gritty details about the Nano Diamond Battery. And there aren't even video demos of the technology yet. But the promise of the radioactive diamond battery is still very real. And NDB's forthcoming smartwatch will tell us a lot about the feasibility of such technology in other applications. And we'll be waiting. All we have is time.